I'll begin by just giving a 5 minute presentation of what this meetup is about, and then I'll hand over to Krish, who will be presenting the project for today. So, we are already on the 8th meetup, and we just started last month, so I think this is a good progress for us. The agenda for today is, after my introductory presentation, there will be a project presentation featuring the use of Webots, also talking about ROS for a robotics project, and a competition that Krish participated in. And after that, we will have a question and answer discussion session pertaining to the topic, and Krish will also be sharing the code base basically. Uh, After that, typically we have a section called project accountability share, and typically someone who is doing a project, he can share his progress during the meetup, and the goal is to just keep the person accountable. And after that, we will just have introductions and casual networking, and we can get to know each other in a more casual way. So the primary focus of this community is learning about robotics and artificial intelligence, and we are also exploring new ways of learning, and exploring new educational platforms, and that's why edtech and entrepreneurship also come into play. The way we learn is that we conduct weekly meetups and monthly research paper discussions, one of which was conducted last month. And we also have a project accountability session, a part of which is talked about in the meetup, and another part is just on the Discord server, the details of which are in the server welcome section itself. And we are a volunteer driven community, and the only way we learn is if someone volunteers to present his or her projects, or in some of the cases we have also tried discussing about concepts like computer vision, where individuals prepare their presentations on their own and discuss it, and these are the ways that we learn normally. So I would highly encourage everyone to volunteer either for the meetup or for research paper discussion. And that's all from my side, and now I'll hand over to Krish, who will be presenting about Webots and ROS in robotics. So Krish, over to you.
Yeah, so hi guys, Krish here. So I will just present my screen and just uh, is the presentation visible? Just confirm.
Yeah, it's visible.
Yeah. So this presentation is mainly going to be about Webots. The ROS part is where I am not familiar about, but I do want to have a conversation around ROS with you. If as I know, some of the members already have a lot of experience with ROS, so the flow of this presentation would be to explain about what is Webots all about, and maybe explain about the competition where I was exposed to Webots, and then maybe discuss a bit about uh, what should I do next in my life or career. Yeah. So as you already know, I am Krish and I am 17 and still in third year of high school, which is, very young for me to be already in this community, as I have received various compliments from various members on this server, and I am mostly into core robotics. I mean, I just try to, understand what is robotics all about and all the various topics that involve around robotics. And right now I'm working on this website of mine, which is like a startup called ideobator.in. It's still work in progress, but I want to, you know, it. I want to make it presentable by the end of this year. So yeah. So what is Vbots actually? So Webots, if to understand Webots, it's like a platform where you can simulate robots, and it works on all three systems, that is Windows, Linux, and Mac OS. And its main goal is to, first you can maybe model your robot in CAD or using any other software, and then using that you can import that same model into a simulated environment inside Webots, and then you can write some code and then program the same robot, and then you can start simulating in that same environment, and then you can transfer that same thing to your physical robot. So let's say there is a Tesla car, and you have the same model for the Tesla car in Webots, and then you just want to, first simulate it in the virtual environment, and then using the code base in the same environment, you can use that and transfer it to a real Tesla car. I mean, there will be some complications inside the real world, but it is manageable, and it has been designed for like various uses. It's used for professional use in the industry, for education and research, and it's not that popular as ROS, but I guess this is a very strong software. If people start using this, I mean, it's like a wonderland. So yeah, moving on to the next slide. So the competition which Chandan was talking about is called EYSRC. So EYSRC is just a short form of eYantra School Robotics Competition. So eYantra is a initiative started by IIT Bombay or Indian Institute of Technology Bombay, and they would do the robotics competition for the for the college students who are who are doing their bachelors. And this year, due to the pandemic happening and stuff, they even extended this same initiative to the school students to make them understand about robotics. So through this competition, the main concepts that I learned were Python programming. uh, Python was the main language that we used to use, control, and run our robots. The second concept is differential drive. So we learnt about how we can use only two motors and two wheels to, control a robot. And then we understood the use of proximity sensors. I mean, how do you use a proximity sensor, and using the knowledge of the proximity sensors run a robot. And then we even were introduced to rotatory encoders that are that is just the opposite of a motor. If I want to put it in words, I mean, it's not exactly what I'm saying, but yeah. And we were explained the difference between and what is open loop and a closed loop controller. And talking about controllers, we learned about various controllers like uh, PID controller, which is a widely used, and it's like regarded the best controller, I guess, in the industry. PID controller. So we were taught about just the P part. The IND part was not taught because um, there were teams from lower grades as well, lower standards like 8th and 9th standard, which were in like in primary school. So explaining the proportional part was just done, and we learnt about a Bratenberg controller, which I was never heard about, and it's a very interesting controller to talk about. And there was a Bang Bang controller, which is oddly simple to understand. And then we learned about a bit of CAD modeling ourselves. I mean, there was a bonus task that was attached to this competition. So thereon, our team learned about CAD modeling a bit ourselves, and then uh, in the finishing tasks, we learned about image processing, where we learned how to recognize a color or a shape. And we even went ahead and learned about how do we use image movements to calculate the centroid of an image. So I will explain what all we did exactly. So the tasks 0 to 3 constituted our phase 1 of the competition, where we where this was the first task of ours. So in this task, we were just taught how to use the keyboard as an interface to control a robot, and we had to just use our robot to make it run in some sort of a square. I mean, it had to cross all the four squares of the arena. And yeah, so that was the first task about. The second task was where we took a very big jump. The second task was about, you know, learning about differential drive, what is it all about. And using differential drive, we were made to learn about tracing shapes like circles or squares. So the part where we were taught about how to trace this line or even this line with changing radiuses, we were taught about how to calculate formulas for it. So we used a lot of geometry in this task to understand and use those principles to make the robot follow this particular shape. So this was actually an open loop control, and this task was about where there will be a set of boxes that will be randomly thrown all over this arena like this, and we had to ensure that the robot avoids these boxes and reaches this finishing line. So in this task, I guess this task required our team to do the most of the coding, where we implemented a algorithm such that if there is no box in front of the robot, it realigns itself to make it straight and then move ahead, so as to reduce time, because time was actually the main factor while ranking us in the leaderboard. And this task 3 was about following a ball. So actually this arena is uh, w- type of wall. I mean, you could either follow the left or the right wall, or even both. And then using that, we had to make the robot follow this. So this is some sort of a flyover around here, and then this comes down through this ramp, and then it goes, and then it finishes. So yeah, so this was the phase 1. And then the phase interface between phase 1 and phase 2 was the bonus task, where we had to make a arena of our own, and using that using the knowledge of the other tasks, we had to design a course of our own. So we took COVID-19 as a theme, and then we explained about the struggles of the student life, how it affected the lockdown and everything. I mean, we had made a separate video for that, explaining the struggles. And as the video was playing, the simulation was also running, because this simulation is quite big in terms of time. So here we followed the wall, here we did obstacle avoidance, here we did shape tracing, and then here we again did wall falling. So the bot was going in and out of the 2020 symbol, or whatever you want the shape, and then it was reaching this end. Yeah, so the next phase was where we learned about image processing primarily, where in this task 4 there was uh, there was a box, and the box had a particular shape with color. So there were only two colors around which all the shapes would be randomized. It was either blue or either green, and there were four shapes. There was there was a circle, there was a square, there was a pentagon, and there was a I guess I don't remember about the shapes, but the main purpose was that using the color, it would turn left or right, and using the number of sides or the shape, it would turn that many. It would use that value to make the robot run that much distance. So as soon as the boxes appeared on the way, it would analyze them and then move ahead and finish the task. So there were 7 iterations of this whole thing going on. This task 5 was where we were made to follow the line with a rather different approach. So usually we see line followers where we use IR sensors to basically make the robot follow the line. But in this task, it was quite different. So we actually used a camera which was provided on this robot. So this robot name is Epoch. So this is made by GC Tronic. You can find a physical version of this in online stores, not popular online stores, but it's very hard to find back in India here. But I mean, you can make a similar robot of such sorts yourself as well. And using the concept of image movements, which I talked about, we used the centroid of the particular image, and using that, we implemented the proportional controller, which is the P part of the PID controller, in such a way that it would follow the line. And then there was the final task. The final task included the wall following and the line following simultaneously. So the wall following arena was same throughout the whole course. The line following arena had two iterations, so it would randomly change around the code. Uh, as we are running the simulations, it would every time change to a different map, or it would not. It was always randomized, and and when uh, w- the moment when we had to change the algorithm from wall following to line following, the this this particular red tunnel came in very handy to us, because if so what we did is we made an algorithm in such a way that anytime it would detect the color red, it would change the algorithm directly to line following. And using that, we even said that if there was a continuation even after the line falling, a similar tunnel of other color as well, if it was even green or blue, our algorithm was so much robust that it would always change into a different algorithm as we wanted. And there was a viva in this final task. So it was a panel of judges from various departments of IIT Bombay. So we were asked what challenges did we face in the final task, or how would we handle if there was a case where the line following arena had a zigzag in it, like a resistor. Then we were asked a question around what if the whole setup, this setup was shifted into a different room with different lighting conditions. So what variable would we change in our code? And the last question was, what is the proximity sensor about? So it was a hardware related question. And then after the viva, the next day the results were announced. So our team, that was named Scambots, we won the award for the most beautiful code. And if and I have the code base ready as well. So this was the actual arena where we tested. So we can discuss this code base during the discussion if anyone wants to ask about some algorithm. So one more thing, as you guys know about ROS, and I don't know about that much. I mean, before starting with Webots, I was experimenting around ROS. So the only uh, disadvantages, or negative things that I found about ROS, that it works only on Linux systems right now. I mean, the documentation says it is trying to implement ROS in Windows, so it just works on Linux systems right now. The initial installation of ROS is very tedious. I haven't installed it. It's not working for some reason. But saying that, actually, ROS now uses Webots as a simulator, which is like Gazebo. So Webots is a simulator in some sense, but ROS as well. So I'm just giving a vague idea. So Webots actually does the same work which ROS would do, but ROS uses Webots as a simulator, just like Gazebo. So yeah. So now we are open for the discussion. Yeah.
Yeah, thank you for presenting, Krish. I think We can also let's first address any questions that we have first, and then we can discuss the code base, I guess. So if any one of you has any question, you can just ask right now. Actually, I think ROS is not just for Linux. I think it's also available in Windows. Although
Yeah, so
I've
that
not
is
used it.
so that is actually right now in testing, as the documentation says.
Okay, okay.
I mean, you can use ROS on Windows, but it would give you a lot of errors that Linux wouldn't.
Not very stable. So yeah, I have used only on
Yeah.
Linux. On that, it's uh, fine actually. Uh,
Yeah.
yeah. So Webots is the main operating system for which Webots is used is Windows, or is it available in all of these operating systems?
Yeah, it is available on all Linux OSs, on Windows, all versions of Windows, I guess. I mean, the newer versions after Windows 7, and Windows 7 included, and even on Mac OS. I don't know after which versions it supports. I mean, I don't use Mac OS right now. I mean, this is my Linux system. So, yeah, but I know it works on Mac OS as well.
Okay, yeah, sounds good. And now we can discuss the code base, I think.
Hmm. Yeah. So, any questions before anything related to the code base? Any particular algorithm which you want to talk about? Because the whole code is around 300 lines with 12 functions all around. So, if you want to discuss any particular algorithm, any particular function, I can talk about, or I can just run through the whole code. Any questions before that?
I guess no. So you can
Yeah.
I guess quickly skim through the code to explain the whole structure and the
Yeah.
algorithms implemented.
Yeah. So this is the code. I mean, first of all, we import and call all the important libraries that would be we would be using to run the Epoch robot through this arena. Then we basically make a initial we make instance for the robot for the program, and then we make an instance for the camera, and we even initialize the time step value. So if anyone doesn't know what time step is about, if I wanted to explain it in layman terms, we can understand in that if suppose on a windy day, if you're throwing a ball from your top floor and the ball is traveling down, and if you don't know anything about physics or maths, you can just take out your phone and record a video of the ball falling. So at each instant as the ball is falling down, you can divide it into certain frames, and each between each frame there will be a particular time interval. I mean, if the video is of 10 seconds, I mean there would be the frame would be of 1 second each. I mean, that's just a vague example. So the value of time step is that value of the 1 second. So here in this program it is 32 milliseconds. So if I run the program, uh, uh, yeah, so as soon as I do this, so actually this is traveling 32 milliseconds per click. So if you notice, it's 40 right now, then it turned to 72, 672. So it's like 32 milliseconds, it's increasing by 32 milliseconds per click. It's in a way it's helping us calculate all the physics that include gravity, friction, um, and any other relatable stuff, even rolling friction and stuff like that is calculated. And then we just initialize the proximity sensors. There are actually eight sensors on this, eight proximity sensors on this robot. So we are going to use the first and the sixth sensor, which is one second. Uh, uh, yeah. So these colored ones, this is the sixth sensor and this is the first sensor. So this is the 0th, the 7th, the fifth, the second, and so on. And then we initialize some important variables like max speed. So the max speed for this is 6.28 radians per second, and some other variables which I will talk about. So this first function is where we initialize the proximity sensors so as to we could understand how for the code to run. I mean, uh, it would be difficult if we would not convert the values over there to this, and then we use those proximity sensors values in this function where we find the error. So first we inverse the value because what this does is as we move towards the wall, the proximity value increases. So in order for us to make it more readable, we just subtract it by using 255 minus the actual distance which the proximity is throwing. In a way, as we move towards the wall, it's not 255, it's 0. So using that, we are calculating the error and then we are normalizing it so that the range of the error is it's like it's between -1 to 1 approx. I mean, it not for this, for the other thing. It's and then what we done is we are using the P controller over here to make the robot follow the ball. So this is kind of a different P controller which we use. So what we have done is we have used this the values of the error values from the proximity sensor, and then we are telling the bot if it is moving more towards the left wall, it will tell the robot to turn right, and vice versa for this sensor. So in a way, it's always telling the robot to turn left and right in such a way, and the P controller it is making it very smooth. It's not like a bang bang controller as we see. It's very smooth due to the proportional controller. And then there is a function where we convert the image into a numpy array using the functions of the numpy array, and then we use this function to always make the robot find if it has reached the tunnel or not. The color of the tunnel can either be red, green, or blue, which were the hidden test cases that were given to us. And then uh, if the robot finds the tunnel, it just basically escapes it straight away, and it will just pass through blindly like an open loop control. And then we find the centroid of the when the line falling starts. We actually what we do is first convert the image into grayscale because uh, the threshold function which we use next can't handle three channel images, so we are using one channel image, and then using that we are setting a threshold value. So what this does is basically the black line is getting converted to white and the white space is getting converted to black, and then using that knowledge we're calculating the centroid, and then using the centroid we're calculating the error from the preset center value that was 25, and then we are normalizing it. So it's exactly between -1 to 1 in this case, as I said earlier. And then we have used the P controller again over here, and over here other teams what they actually did is that they wrote an extra piece of code over here saying that if the bot does not see a line, so the value of the contours value of the line is 0, it automatically turns to the left, keeping in reference from the last major values that was in the code. So it's pretty difficult to understand that, but we have but in our code we have implemented it very simply. It's just calculating the centroid, and it's using that centroid's value to calculate the error, and using that error we are um, using the p controller. And then there is a function of cap and move. So what cap and move does is, if the speed of the motor exceeds max speed, or if it is less than minus of max speed, it basically equates it to that, so as to avoid errors in the code, in the console actually. And then using that, it just sends the values to make the velocity of the wheels of the epoch robot to that. And then I made two different functions to follow the wall and follow the line. So if you can see, there are two common functions, cap and move, over here and over here. So if there is any other algorithm, this app and move function can be used anywhere, because any which ways we have to make the robot move any place. And then um, uh, so what we have done is we have made three modes. So mode 0 is for wall following, mode 1 is for escaping the transition tunnel, the red color tunnel, and then mode 2 is for following the line. So it's preset to mode 0, that is the initial mode to make the robot follow the wall. And then uh, if uh, if the mode uh, is 0 and then it finds the tunnel, then it switches to mode 1. And if the mode is still 1 but the color is not red, I mean the color of the image is not red, it turns to mode 2. And using those values, I've just made three if conditions. If anywhere the mode is 0, 1 or 2, it would follow the wall, or even escape the tunnel, or even follow the line. So this was our code about. The main code is this. So actually this does all the trick. This 10-15 lines, the above code is where we have implemented, where we have initialized the functions. Yeah, so this was the code. This was our code base.
Great. Does anybody have any question regarding this? I think not. I think it was pretty straightforward and easy to understand. So yeah,
Yeah, I mean, we try to keep it very simple for other teams to even understand it.
yeah. That's why it was the most beautiful code, right?
Yeah, I guess. And the outcome of that award was that our team won a drone, and for our school we won a Raspberry Pi kit and other goodies. So yeah, that those were like the goodies, and we even won a cash prize. So that cash prize was basically the fees that we paid for registration.
Okay.
So we got that back as well.
That's great. And regarding the theoretical concepts that you mentioned initially, was there some training module that they gave, or you had to?
Yeah, yeah. So there was a separate website which was encrypted. I mean, there was a particular username and password you had to enter to
Hmm.
get into the that website. So we would call it the MD book, although I don't know what the full form of MD book is till now. But there we had a separate learn section where you would learn about the concepts, and there was separate sections for all the tasks from zero to the final task, where the problem statement was made to understand the concept of the robot. And so the
Krish,
original Yantra organization. Yeah.
sorry, I think we
Hello.
lost you for briefly
Okay.
because of internet connection. I'm not sure if it is from his end or my end, but can you guys hear him? I think his internet is having some trouble there, right?
Yeah, I think so. I can't hear him too.
Yeah, okay. Hmm. Okay. Okay, I'll just write to him that his we are not able to hear him, and meanwhile we can start with the next part, which is just introductions, and you can also give feedback on the presentation or general about the meetup format or anything else you would want to talk about, and after giving a brief introduction. So so I guess let's start with Johannes. This is the first time you're joining, so
Just introducing myself, or what's the?
yeah, just introducing yourself. Before that, just a moment. Let me see. Uh, let me get in touch with Krish about his internet.
Am I audible right now?
Yes, now you're audible. Yep.
Yeah. Yeah, so I was saying there was a particular team that did not understand English that well. So their teacher helped them convert English into a regional language of India. Then they progressed afterwards, and they actually won the Judges' Choice Award later. So
Ah.
we got a lot of inspiration from them.
Mm-hmm.
Yeah, and there was even a team who had an art student in them, and he explained us how his knowledge would help in a in tasks that were related to science and engineering. So that was again a good example.
Mm-hmm. And I think it's really cool that you have you have the opportunity to participate in robotics competitions at such a young age, so you get involved with science and technology, and in a practical way from a very young age. So I think that's really good.
Yeah, I mean, other countries do support students to start at a young age. India is late, but nevertheless, it's catching up, I should say.
Yeah, yeah, that's a good thing. Okay, let's proceed with the introductions and casual, yeah, just talking about the stuff and robotics and everything in general. So yeah, moving to Johannes.
All right. Yeah. First of all, kudos to Krish. Very cool presentation, and congrats on your contest winnings. Uh, I agree with Chandan that it's great that you get started with it at such a young age, and seeing some success already, and yeah, that's really great to see. Um, yeah, as for me, I'm a PhD student in Germany, in Aachen, and also a research assistant at RWTH Aachen University. And I'm basically, so I have no idea about robotics, which is so for me it's really interesting to get a glimpse into robotics here in the meetup. But what I'm studying mostly is computational social systems, like social media networks and so on. And yeah, I'm trying to understand what algorithms do in that regard, like how recommender systems affect the outcomes of social media platforms and so on.
Yeah, Yeah, I mean, we've talked about your research interest before as well. I think that's pretty interesting, but also very complicated, the area in which you are involved in, right?
Yeah, true. That's true. It's really off topic from the robotics world, so I don't want to get into it too deeply. But yeah, that's maybe sometimes you find surprising connections. So, for
Yeah,
example, I'm also doing a lot of agent-based modeling, which is also a
yeah.
simulation technique. So it has some similarities with what Krish has been doing. Um, like I recognize some concepts from the simulation perspective.
Yeah, yeah, and in research, it's like the more ideas that you have, the more papers you can probably publish, and I mean, you would probably be more excited about your research. So you get probably more ideas when you encounter new and different kinds of projects and fields. So probably that motivated you to uh, be involved in this.
Yeah, that's right.
Yeah, good to have you, Johannes. So moving to K. Om Prakash.
Hello everyone. I'm an
Hi.
undergraduate student. Hi. Hello everyone. Can you hear me actually?
Yeah, we can hear you,
Hello.
but I think it's your voice is breaking. It's not totally clear.
Okay. I just want to congrats Krish because he just achieved a great achievement in the his young age. He has done a great work. I'm an undergraduate student. I don't know much of the things. I don't have any prior experience in these cases. I study in India itself. I'm studying robotic and automation BTech.
Okay. Yeah, I think we missed some portions of it, but overall, I think it was clear you are an undergraduate student in India and you are looking to explore more uh, in robotics. So, welcome, Om
Yes,
Prakash.
yes, yes,
Looking forward to seeing you in the subsequent meetups as well.
definitely.
Yeah, and so moving on to Naj Zero, I think Najwa, you were there last time as well. Could you briefly introduce yourself?
Hi, just a second. I'm Najma. I'm a master's student in computing. I'm also working as a research assistant uh, in the computer vision field. I'm interested in anything related to computer vision, robotics. Currently, I'm also taking a course in robotics, introductory course though.
From where? From Coursera, or which course are you talking about?
Um, it's part of my master's.
Ah, okay. Mm-hmm.
Um,
Okay.
so yeah, so to actually, I did something related to soft robotics, a training, I did a training. If anybody knows about it, like crawler robots, gripping robots.
Ah, interesting. So, but that's
Yeah, I
more
have
in
heard of
the
them.
hardware side, right?
Yes, yes, yes. So you would have to control the actuators. That's another
Okay.
thing.
Hmm, hmm, hmm.
Mostly Arduino controlled. This was kind of like an introductory session. Not, I haven't gone deep into it.
Okay, yeah, that I think soft robotics is another one of the uh, emergent areas in robotics. Pretty interesting. I've never actually uh, worked in this particular area, or heard about it, or have any details about the projects. So maybe sometime you could also share details of some of your projects or anything, if you're
I
interested though.
haven't, yeah, I haven't done anything yet. Um, because I think it needs dedicated curate and chemicals for this to make the resin and all that, as much as I have learned. Um, but I'm trying to do a short review on this. If I finish it, probably I can. So,
Yeah, okay, interesting. Okay, thanks for joining again, Najwa. All right, so Nimisha.
oh, one more thing. I was just wondering. I think Krish who presented. Am I correct?
Yep.
Yes. Um, so I want to ask, you use simulation robots, am I right? So actually,
Yeah.
I've taught
Yeah.
kids robotics, but mostly with Lego EV3.
I have used. I have the kits for that at my
Uh,
home right now. So
all
yeah,
right,
I sometimes use that. I mean, I haven't been. I mean, it's a long time. I haven't used it, but I use it for. I use the parts for making some kind of mechanical projects. Like I have made a stand for my a phone that I could attach as a webcam on my laptop. So yeah, so I try to experiment stuff.
with the Lego parts.
Yeah, with the Lego parts. I mean, I'm not that into EV3 because of the interface, the coding interface. I mean, I just hate block coding for some reason. Then I entered into the MicroPython thing, which EV3 has presented, and then after that, actually my board exams came, so I wasn't able to focus that much. But I guess this year I will try to pay a more attention to that, towards the physical robotics side. I mean, let me get over with the simulation base. I mean, Webots actually has a Lego Mindstorms robot available as a robot like ePuck, which I explained. So you can add also that, and you can even code the same thing for it. Yeah, it's interesting.
So I was just wondering, the curriculum that you had, you were talking about PID controllers and all that, which is a bit advanced. I wouldn't teach that to my kids yet. At this, I mean, probably I used to teach 13-year-olds, 14-year-olds. So I was just curious how they introduced that to you.
I mean, the first ever actual lecture that we received was about differential drive. So thereon, we were introduced how to trace circles. So let me show you some type of documentation that they give. Just give me a second. So they explained us the whole shape, the whole thing using geometry. So that was understandable
Wow.
to a lot of us since we use geometry in our school curriculum.
Okay.
Yeah,
Interesting.
uh,
Congrats, by the
yeah,
way.
yeah. One second.
Thank you.
Yeah, that's so the things that
Yeah,
they.
so
Are you sharing a
if
screen?
you see my screen, yeah, I'm
Okay.
sharing a screen. So this is the kind of stuff that they give. So this is just an example. There is a whole lot of stuff that they gave to us. So through this diagram they tried explaining us how do you exactly shape circles or trace circles using differential drive. So basically you have a wheel that has a more velocity than the other wheel, and using that, so there was a lot of geometry, a lot of formula calculations going around. And then there was a part about proximity sensors and coders, and then how to use controllers like wall following controller, bang controller, proportional controller, a line follow controller. Then there was a part about image processing, how to use OpenCV, watercolor models, thresholding, finding and drawing contours, shape detection, color detection, and finding centered finally. And this was the problem statement of all the tasks. This is just a rough idea of how to of what the task is about. And there was a part before this explaining about Python, so this was actually needed. And there is a part where you are explained about Webots. So how to use Webots, how to make your own arenas on Webots. So it was so this is the whole documentation which I was talking about. Yeah.
Looks very interesting.
Yeah, that's very detailed actually.
Yeah, we needed to go through that. So we were given a time of 1 week. Some tasks they eventually gave us 10 to 14 days. So 3 to 7 days were increased on some tasks because of the varying difficulty. So yeah, it was a good experience.
Yeah, and you learnt a lot as well there, so really good. And you eventually grabbed an award. So
Yeah, I mean, we were never expecting that awards will be such, because earlier we were expecting there would be according to our marks. Then later on we got to know that there was not that type of award system. So it,
yeah, okay. Moving to Nemisha for her introduction.
Yeah, hi. I'm currently in my final year of electronics engineering from India, and I'm new to robotics. Yeah, I look forward to learn something new.
Where from India are you?
Mumbai.
Mumbai. Okay. And you are into electronics and you are interested in exploring robotics.
Yeah, I'm planning to do masters maybe
Okay.
after 1 year.
Mm-hmm. Okay, interesting. Welcome, Nemisha.
Thank
Nemisha,
you.
sorry.
Yeah.
And moving on to next, Mr. Nobody 29144. Could you introduce yourself?
Hello, am I audible?
Hi, yes, you are.
Yes. Actually, I have attended previous meetup of computer vision. My name is Virendra. We had a talk about
Ah,
ROS. My
okay.
pro.
Hmm.
Yes,
I
yes,
think on that meetup you weren't nobody, you were a, somebody, right? You
yes,
had your real name mentioned there. So.
yes, yes. So, like this is the name which I give. Yeah. So I am a third year undergrad, and I'm pursuing electronics and telecommunication. So I've joined this meetup for ROS related things. Though I couldn't give time for this, I got to know that one of the member knew about soft robotics. I would like to ask her that I want to design a gripper for that. So means like afterwards, could you help with any details about this, from where to get started for this stop? And that's all. I am third year undergrad, currently doing projects on ROS, and I am also working on 4 degrees of freedom robotic arm, and it will sort uh, a fruit based on its ripeness. That's it.
Okay. Nice,
Okay.
Virendra. Welcome again.
What did you say? What do you want from me? Could you repeat that, please?
Actually, I want to
Actually, I
design a
want to design a
Gripper.
gripper for my
gripper
means
for my
arm.
arm.
So
Okay.
after
So
yes,
after yes,
after designing
after
a
designing
gripper.
a gripper.
I can't
Hello.
hear you though.
Hello.
Hello.
Najma, just
Najma, just
mute
mute
yourself.
yourself.
The voice is echoing. Yeah.
I guess now it's not echoing, right?
It's
So I want to design a gripper for a arm. So wherein I want to use a means like soft robots. Means like those EcoFlux chemicals. Uh, One thing is that I want to have means like three clamped or four clamped fingers, claws, like thing to pick a fruit. Wherein conventional grippers like two claws or two finger grippers wouldn't do much of the task. And the second thing is using the pneumatics over there. The things would help me because I need a compliance gripper, not a conventional gripper. Compliance is the thing where you can easily grip a egg, but if a gripper is not compliant, then it would crash the egg. It's like you could have imagined what I actually need. Soft robotics is a best substitute for this one. So I want to know that how should I get started with this?
Oh, I guess you know more than me, so I really can't help you out more than this. Actually, the instructor had a GitHub account where I really actually forgot her name. I think her name was Adriana. Shared an account for all the experiments she did with the soft robotics. So if you maybe search for on GitHub, probably you get some ideas. I'm so sorry, I can't help you more.
I actually have a kind of a suggestion for nobody. So, what my suggestion is, I have seen there are robots that don't use the gripper as a finger. So, that gripper is actually some kind of rubber flap, and using that rubber flap, when it approaches the object, the rubber flap is kept on that object, and there is some sort of suction created. So, actually the arm is some it is picking up that object using surface tension, I guess. And then any the object of any shape, I mean the gripper can itself mold itself to the shape of the object and then pick it up. So if that is possible for you to build that, I mean that approach would be the greatest approach in my mind. So if you can, you can try that.
Yes, yes, I got to. I understand your point that it's known as suction gripper. Those are inflammatory, means like they inflate, like how a balloon inflates. Those grippers also inflate. They are used as internal as well external grippers. But those grippers you needs extensive power. Like we need a large PSI, means pounds per square inches of pressure to operate those. And wherein I was thinking of substituting it with a very means like low energy consumption part of it. That's why I was
Yeah, yeah. So I said there would be some limitations to this as well. Yeah, I mean that project is approachable, but you kind of need the correct equipment to perform that. Yeah.
yes, yes. Though I will again think about this on your suggestion and figure out things if they are working on it.
You can also probably post
Yes,
it on one of the channels, probably in chat room or general help section. Yeah, I think you can have a discussion with the members here.
yes, sure. Thank you.
Okay, all right. So yeah, I think that's it for today. And before leaving for the next meetup next week, I just want to ask you if any one of you wants to volunteer for the next meetup. So any project or any idea that you want to share, that would be Great. Yeah, if anyone wants to volunteer, you can either say now, or you can also write in a Meetup volunteer section in the events category, and I'll fix your appointment, and then you can speak next week. And another thing, normally, as I mentioned, we do one research paper discussion uh, per month, and that research paper discussion is really supposed to be intense and cover specific details of the paper, including probably also the mathematics. Sometimes the last time I didn't share mathematics, I shared a reinforcement learning paper, and I covered the overall idea because I think it was really challenging to cover it in 1 hour. But for this month, we actually ideally should be having a research paper discussion tomorrow, but we don't have a volunteer, and I also don't have some presentation of a research paper prepared. So regarding that also, we need a volunteer. If any one of you has an existing research paper studied, you probably don't have to do a presentation. If you can just also explain and give the core ideas, we can continue with the regularity of research paper discussion as well. So this is something that we plan to do every month, once a month research paper discussion, and every week we'll be continuing with the meetup. So yeah, I just want to ask you all if anyone wants to volunteer. Or plan to volunteer at a later stage as well, and what kind of ideas or projects do you plan to share, for example?
I wanted to do kind of idea pitching sometime if everyone is free. I mean, most of the people about the same website which I discussed. I mean,
Mhm.
it's some in some way it would help you graduates as well. I mean,
So idea
I
pitching,
have
sorry, yeah, continue.
yeah. Yeah, so it's some kind of platform where you will give mentorship to high school students and even to college graduates. So if you're interested, I mean, you would obviously, there is some kind of money aspect to this as well. So there would be earning. So if you are interested, I mean, I can do a idea pitching sometime later, this week, this month, next month. I would be glad to do that.
So idea pitching specifically for startups, or general any project related ideas? So you're talking specific to startup, right?
It's yeah, it's like a startup, but that startup would eventually uh, make you guys talk about projects inside it. So it's like a box in a box. So you can
Okay.
get the idea of that. Yeah.
Yeah, we can discuss this, I think, after uh, the meetup, and see if we can plan something. So by the way, regarding the what, I forgot the name of the idea that you're working on and planning to implement by end of
Ah,
this year.
so, so yeah, so the website's name is Ideabator. So it's idea plus incubator. So you can remember that. I mean, I could not find a better name than this. I think I might, but at the moment it will be this, and the website is still under development. It's a very small team. So yeah.
Okay, interesting. So so what is the platform supposed to do? Like, what are the features, and what are the customers probably that you're targeting?
Yeah, so the customers that I'm targeting are high school students and first, second, third, or fourth year college graduates. I mean, I know in the fourth year there is something called a capstone project, or somewhere it is also called a fourth year project. and there people students require help, as I know. And if I talk personally about myself, I would not find those mentors 2 3 years back. I mean, I had a lot of projects that I could have done, but there was no such platform that would provide uh, you the same thing at a very low cost. So the platform is where you come in, you have an idea that could maybe turn into a startup, that could maybe turn into a product. And it is not field I mean, it's not field limited, it's not about just science, engineering and stuff. It's about all the fields. I mean, if you just want to write a research paper, a thesis, even let's say in history, or you want to do just you want to create music, or you want to collaborate with some mentor to create a movie, a short film, I mean, you can do that on this platform. So I know a lot of people that are from Discord. So Discord is a very good I mean, community gatherer, as to say. I mean, um uh, I guess I would find some mentors even from this server. I mean, who can later collab with my website, our company, I should say. And then later on, the business model is such that on any one project, everyone would earn some kind of money or share. So I will discuss about the business model in a closed meetup if some people are interested.
Okay.
So yeah, you can either DM me, or we will have a closed meetup. I mean, the people who are genuinely interested in this. So yeah.
Yeah, okay. Yeah, good that you mentioned it here. I think the people who would be interested, they can probably also contact you after that, and I'll also get in touch with you after this if we can kind of have an event or something regarding this. Yeah.
Yeah, that's what I'm looking to have. Yeah, exactly.
Okay. And coming back to the meetup and research paper discussions, does someone have some ideas that you want to present, or which areas are you considering? So far actually we have had a variety of different topics, so from computer vision and deep learning to also uh, control, and also some just specific to the hardware side, and we have also covered using ROS for some of those projects. So actually we are open to any of these areas, including natural language processing, or even data science, or any fields in close association with robotics and artificial intelligence. And yeah, you can definitely
Definitely.
write or talk to me later, or write in the chat room if you have an idea later. Yeah. So yeah, that's it for today. If anyone wants to say something, feel free to say it now before we conclude the meeting. Okay. All right. Then thanks a lot for joining. And we have had another successful meetup session today, the eighth one, and we'll be continuing to do it every single week. And I'll figure out a topic for the next meetup, and find someone, and we'll have another interesting discussion next week. So feel free to give me a personal feedback as well later, if you feel like you should. Yeah, if you have any feedback, you can also give me personally later. So yeah, thanks a lot for joining.